So, a very warm welcome also from my side. So, a couple of weeks ago, I was waiting on the night train, the new night train from ÖBB, going from Amsterdam to Vienna on the railway station in Mainz. It was midnight, so the railway station was completely empty, it was silent. And I was sitting there on the bench, my suitcase next to me, and was waiting for the train. So various trains passed by. First, the commuter train, where you could hear the noise, the characteristic noise when it breaks, the mechanical doors opening, people exiting, entering the train, and also the noise that it makes when it's leaving the station. A couple minutes later, there was a freight train carrying iron ore. And as you imagine, iron ore is very heavy, so it made a lot of noise as it passed right in front of me. You could hear all the squeaking noises and also the characteristic jackhammering noises of the wheel defects going like dum 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 dum. And I was really fascinated in the moment because I could see the train, I could hear the train, and I could even perceive the train. The noise level and the vibrations were even so high that my suitcase on the bench started to move. Now, were these defects, these wheel defects, were they critical or uncritical? I don't know. I recently heard somebody say that the inflicted damage magnitude of wheel defects on the track is still in question. He also sits today in the audience. If that's so, I'll let decide for yourself. Maybe we can discuss about this later. I don't know the answer because I'm not trained to determine that just by listening to wheel defects. But for ages, there were exactly people like that waiting at maintenance yards to check visually and also acoustically with their own senses the magnitude of the damage and what has to be done. And even today, on passenger trains, the personnel is asked to report on vibrations and also extraordinary behavior to save for critical events. These pre-warnings, they do often lead to a premature stopping of the train that costs the train operating companies a lot of resources. Following the principle that everything that you can see, that you can hear or perceive, you can also detect, eventually also learn a machine to come to the same conclusions, helped us in railways a lot. It helped us to improve our operations, our safety, and also our maintenance. Since 2015, Deutsche Bahn is using acoustic sensors to monitor their ICE3 fleet. They were able, just by the usage of 3 of those acoustic detectors, to reduce these pre-warnings that I mentioned earlier about by 95%. This is truly a success story. The way these acoustic monitors work at Deutsche Bahn is similar of what you would call machine learning. So they looked at historic data of faulty bearings, and they looked at the acoustic emission patterns, the characteristics, and built algorithms to also detect the same characteristics in new acoustic data. But where are we now? Computer science, machine learning, artificial intelligence, deep learning, convolutional neural networks, pattern recognition, and many, many more. Those are the buzzwords that we hear so much about, and many of them are even 50 years old, like deep learning, for example. In the last 2 decades, however, the processing power and also the cost of storage has improved to a point where we finally can really leverage those technology. Yet, we often fail to do exactly that. And we are failing to deliver on the promise that we heard so much about in many keynotes, namely, how much can we really exploit our assets, or better yet, how can we build a holistic digital system of our world of transportation and decode the DNA of railways. Today, I want to steer your perspective to something more tangible, or something that I believe is essential in our support of our pursuit of data-driven business environments. I will talk about data quantity, data quality, data exploration, and data exploitation. I am convinced, beyond any skepticism, that railways is the only candidate that achieves resilient and sustainable transportation capacity and growth. So let's start off with data quantity. Imagine the following. You're sitting on an airplane going from Frankfurt to Bilbao, takes roughly 2 hours. You have 2 turbofan engines, and those are obviously in the airplane closely monitored. So there's a lot of data generated on your 2-hour flight. But how much data is really generated? What do you think? Is it 2 gigabytes? Is it 2 terabytes? Or is it even 20 terabytes? Who of you thinks that it could be 2 gigabytes? Please raise your hand if you think, okay? Who of you thinks that this could be 2 terabytes? And who of you thinks that it is even 20 terabytes? Ah. In fact, every second there are 5,000 data points recorded on your flight, summing up to 20 terabytes just in 2 hours. Now let's go to the USA, where there are 25,000 flights every day in average. So the data that is generated by these 25,000 flights is already hitting the petabyte size. Now let's look at a Class 1 company in the USA. This Class 1 company has 1,000 hotbox detection systems, and roughly 150,000 cars go over these systems every day. They have a 40,000-mile network, so you can see there's a lot of things going on. Now think about the number in your head, what you would estimate the data size in this same 2 hours. In fact, it's only 1 gigabyte, so 0.005% of your single flight. Now, I see a little bit of skeptical faces in the audience that see that my analysis is a little bit flawed here, because I am comparing continuous onboard monitoring with wayside monitoring. I'm comparing raw data with enriched data, and you're absolutely right. But think about the following. In Europe alone, 0 flights has crashed in the last year due to engine failures. And we had about, in average, 500 severe accidents in Europe in the railways that could have, where the majority could have been prevented using adequate monitoring solutions. One fact remains, however. With additional monitoring and digital advancements, no matter what will happen, the amount of big data will only continue to rise. There has been a lot of recent progress in data warehousing and other technologies that we can use, but still the true value can only be realized if we use the data effectively. Which brings me also to data quality. The only broadband connection to your brain are your eyes. But besides the machine vision, there's also a quick follower, namely the ears, which you just used to monitor my presentation, as acoustic systems monitor the trains on the track. And combined, those two senses deliver more information than each of them individually. And this is evident that many major railway companies worldwide are switching to a holistic, multi-monitor technology. These involve machine vision, wheel impact and load detection systems, hot axle box detection systems, and also acoustic systems, or each combinations of those. Together, they build a more holistic and more qualitative set so that we can monitor our bearings, wheel sets, truck, and traction. Hotbox alarms for themselves are essential as they are a tool to prevent bearing-related defects. HPD alarms or false rates of HPD alarms cost a lot of money because they lead also to premature stops, and this costs a lot of resources, of course. And in 2014 already, an American study showed that the combination of an acoustic system and an HPD system could be very interesting. What they found out is that the HPD trending data could also be seen in the acoustic data, but not the other way around. So I personally find this very interesting because this means that a bearing-related defect not always automatically generates heat. And this means that the combination of those systems built up a higher accuracy. Together, back then, they found out that this more than 90% accuracy, which was really a huge number back then. Now, 7 years later, we're even much higher than that. In most cases, however, the collected data from different sources, lack of heterogeneity, inconsistency, and also incompleteness, and making our life hard as a data scientist. So what can we do to promote this approach? First, increased standardization of monitoring data, and also to reduce this heterogeneity. Secondly, increase data quality by using a multi-detector approach. And third, promote cross-data combinations and validations to support the quest for deeper understanding of our railway system. Now that we have a quantitative data set, we have a qualitative data set, and we have the point where we go in the exploration phase. That's where the fun begins. First, the exploration. Over the years, one of our clients invested a lot in their wild data, and they stored this raw data. They cross-analyzed this with their physical maintenance activities, and what they found out is that on the bogie, the rubber dampeners, when they start to degrade, they had a significant pattern that could also be recognized by their wild sensors. This is also a very interesting aspect because it means that using the wheel impact and load detection scanners, they can now determine the condition of their rubber dampeners. This example shows how valuable raw data can be. Raw data is your gold, and it can be the key to yet unknown benefits for your business. Investing in the exploration of data, exchanging your data, and also sharing your insights is the key to thrive in the field of data science. Now that you know how you can explore the data, we come to the exploitation part, which is, for me, very interesting because the exploitation means that you can finally use the data for yourself. Let's recap. So we said only the combination of different qualitative data sources together with a multi-detector strategy, the domain knowledge, and also the competence in data science will enable us to get from a basic reading, such as a static load, for instance, to a more complex reading, such as a rich data set that is coming for a supervised machine learning model like a wheel defect classification service. After searching for insights for data sets, building your own artificial intelligence models, having learned to fail and to adapt in uncertainty in your business approach, we change from the exploration to the exploitation phase. And finally, we are able to apply those models, be more efficient and predictable and growth-driven. This is the point where your data suddenly unleashes business opportunities to exploit. Now, this sounds very vague, I know. Yeah. So remember the Deutsche Bahn case? Besides the 95% of the pre-warnings that could be prevented, they also managed to reduce their bearing replacements by 25% just by using these three systems. And also remember the case with the rubber dampeners. They invested a lot in their exploration. So they said by investing in condition-based maintenance, in a data-driven approach, they also managed to reduce wheelset-related train stops by more than 85%. Those are exactly those success stories that many keynote speakers speak about when they say that artificial intelligence will change your business. This is the point where your return on investment really comes back. From my experience, I can say that only close collaborations like voestalpine has with ProRail or other companies, those are the ones, the mutual testing, sharing, improving, exploring and exploiting of these technologies will enable the railway business stakeholders, will enable all business stakeholders to benefit from AI. Before I come to an end, a small thing to remind, never underestimate the challenge that arises from the need to learn and create rules always in the context of the industry operations. What I mean is that real exploitation can only happen when the generated rules and insights are also interpretable by the operators that use these systems every day as decision support and can deliver this value. Thank you very much.
Voestalpine, one step ahead.